Hello student, in today's lecture we will study about equation of plane progressive wave. Equation of plane progressive wave propagating in plus x direction. Okay. Dear student, the general equation of plane progressive wave propagating in plus x direction. General equation of plane progressive wave. Plane progressive simple harmonic wave propagating in plus x direction. Dear student, the general equation of simple harmonic plane progressive wave propagating in plus x direction is y equal to a sine omega t minus kx, where k is wave propagation factor, omega is angular frequency, a is amplitude, and y is the displacement at given time t. Okay, this equation here k is 2 pi upon lambda and v is omega upon k, that is equal to n lambda, that is equal to lambda upon t. N is frequency and v is the speed of sound in a medium. Dear student, remember speed of particles performing SHM remains different at different locations, remains different at different time, but speed of sound at a particular in a particular medium remains same. Okay. In the numerical problem, this formula is utilized in many form. Okay, so this is the first form. We can convert the form like this also. This is another form, y equal to a sine 2 pi upon lambda vt minus x. If it is propagating in plus x direction, here it will come minus. If it is propagating in minus x direction, it will come plus. Okay. The same formula can be written as y equal to a sine 2 pi t upon t minus x upon lambda. Or the formula can also be written as y equal to a sine omega t minus x upon v. All these equations have been written by taking into consideration that initial phase is zero. Initial phase is zero. If you want to solve any problem, you can solve by comparing any given equation with these equation. You can find the result. Okay. Now, dear student, let's learn very important point related to these equation. Okay. What is particle speed? Okay. So, what is our general equation? If we say this is general equation, y equal to a sine for particle having initial phase 0 propagating in plus x direction, y equal to a sine omega t minus kx. Just make the differentiation. If you make the partial differentiation of displacement with respect to time, you will get velocity of particle. So here you keep x as a constant. What you will get? A omega cos omega t minus kx. If you make the partial differentiation, this is what? This is the speed of particle. Speed of particle performing SHM during wave motion. Now let's talk about the slope of the curve. Delta y upon delta x. Here we are differentiating y with respect to x, keeping time to be constant. So very simple, differentiation of sin x is cos x. Okay. So this is a minus k cos omega t minus kx. Okay, what these two relations says, just compare. If you compare these two relations, you will get delta y upon delta t upon delta y upon delta x. You are getting minus omega upon k. This is equal to minus v. So what you are getting? Particle speed equal to negative wave speed into slope of the curve. Okay. Particle speed equal to negative sound speed into slope of curve. Dear student, this formula is very important. How? Let's see here. In the given diagram, see this diagram. If we just look at this diagram, for various position of particle, this is displacement and this is direction of motion of particle. Okay. We are talking for different particle, particle number 1, particle number 2, particle number 3, particle number 4, particle number 5, particle number 6, particle number 7. So dear student, you can see for particle number 2, you can see for particle number 2 slope is positive. Okay, why? Because theta is less than 90 degree. So for particle number 2 slope is positive. If slope is positive means what? Particle speed will be negative because this wave speed remains constant in a given medium. This always remains constant in a given medium, only particle speed changes. During SHM, particle speed remains maximum at mean position and remains zero at the extreme position. Okay, so at point 2, 8.2 particle speed will be negative. So how we will show here? Because slope is positive, so particle speed is negative. At point number 4, since slope is negative, at point number 4 slope is negative. Why it is negative? You can see here. See here. Here theta is more than 90 degree. So tan theta is negative. So at point number 4 slope is negative. So particle speed is positive. Okay. So at point number 4, if location is same, then point number 4 will be vibrating like this. Okay. Now dear student, at point number 1 and 5 slope is maximum. At point number 1 and 5 slope is maximum. So speed is also maximum. So at point number 1, speed is negative, velocity is negative and maximum. And at point number 5, velocity is maximum and positive. Dear student, at point number 6 again, slope is negative. Slope is negative means velocity is positive. Okay. This is at point number 6. And what about speed of particle at point number 3 and point number 7? At point number 3 and point number 7, slope is 0. Dear student, at point number 3 and point number 7, slope is 0. So velocity is also 0. 8.3 and 7. Slope is 0. So velocity is also 0. Okay. Now we are again differentiating the given equations. What we got? We have equation like this: y equal to a sine omega t minus kx. So if we make the differentiation, partial differentiation delta y upon delta x, what we got? ak cos omega t minus kx. If we again make the differentiation delta 2y upon delta x, this will minus ak. Differentiation of cos is minus sine. And dear student, differentiation of omega t minus kx is again minus k. So this we will get AK square minus 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 sine omega t minus kx. This is delta 2y upon delta x square. This is, let's say, equation number 3. And if we make the differentiation, partial differentiation of y with respect to time, we will get delta y upon delta t, we will get a omega cos omega t minus kx. Again make the differentiation, delta 2y upon delta t square, we will get a omega minus omega sine omega t minus kx. Okay. If you divide these two equations, what you get? Divide equation 3 with equation 4, what you get? Delta 2y upon delta x square upon delta 2y upon delta t square. You are getting k square upon omega square. What is k square upon omega square? That is 1 upon v square. Okay. That is what? 1 upon v square. So dear student, delta 2y upon delta x square equal to 1 upon v square delta 2y upon delta t square. Any equation satisfying this relation is the equation of wave. Any equation satisfying this relation is the equation of wave. Okay. So this is how you can define, you can solve any problem if any equation is given, and in the equation, if it is asked to prove whether the equation is the wave equation or not, you can easily prove. Okay. Now, dear student, in this graph, A is amplitude and T is the time period. Time period equal to 1 upon n. Wavelength is what? Distance between two consecutive particles in same phase. Okay. And wave velocity that we have shown. Wave velocity is what? N lambda. Now, dear student, let's see one relation. Phase difference and path difference and time difference. This is the relation to convert. Phase difference upon 2 pi equal to path difference upon lambda equal to time difference upon t. In this question, a progressive wave of frequency 500 Hz is traveling with a velocity of 360 meter per second. How far apart are 2 points 60 degree out of phase? 60 degree means how much? Pi by 3. 60 degree means pi by 3. Okay. So phase difference is pi by 3. What is relation? Phase difference upon 2 pi equal to path difference upon lambda. And what is lambda? Lambda in the question V upon N. This is 360 upon 500. Cancel this 0, 0. This is 18 upon 25. Okay, substitute the value. 18 upon 25. So this was 6. This will be 3. Okay. Pi pi got cancel. So dear student, you are getting delta equal to how much? 3 upon 25. This is in meter. 3 upon 20 mean this is how much? If you write 300 upon 25 into 10 to the power minus 2, this is 12, means 0.12. So answer is option 4. So out of 4 options, the correct answer is option 4. Out of 4 options, the correct answer is option 4. Okay. Now let's see another question. The distance between two particles on a string is 10 centimeter. It is the distance. If the frequency of wave propagating in it is 400 Hz, frequency is given 400, speed is also given 100 meter per second, then the phase difference between the particle, very simple. See here, frequency is given, speed is given, so we can find lambda. Lambda is what? Wavelength v upon n, 100 upon 400. This is 1 upon 4. Distance between the particle is given, that is path difference is given. So what is formula? Phi upon 2 pi equal to delta upon lambda. Delta is given 10 centimeter and lambda is, this is 1 upon 4 meter, means 25 centimeter. So dear student, phase difference is 2 pi into 10 upon 25. Cancel this with 5. So this is 4 pi upon 5. This is the phase difference. Okay, 4 pi upon 5. 4 pi upon 5 means what? This is 0.8 pi radian. So out of 4 choices, the correct choice is option 1. Out of 4 choice, the correct choice is option number 1. Okay. In the question, if v equal to 100 meter per second, speed is given 100 meter per second, frequency is given 50 hertz, then find the distance between the particles who have phase difference pi by 3. Very simple. Speed is given 100 meter per second, frequency is given 50 hertz, so lambda can be found. Lambda equal to what? V upon n. So this is 2 meter. Now find the distance between particles of phase difference upon 2 pi equal to path difference upon lambda. Phase difference is given pi by 3. Delta upon lambda. So dear student, here pi will get cancelled, 2 will get cancelled. So delta will be what? Delta will be 1 by 3 meter. This is the path difference. Okay. This is the path difference. Okay. Dear student, in the next lecture, we will look for superposition of wave. Okay. Thank you.